Good evening. Well, let me share my screen. We were working on work energy power, and in that we were, yeah, fine. So now the question is, okay, let me just recap what we have done so far. So we have seen about work energy theorem, when to use, how to use, and so on. We have seen different cases, and for each problem, at least one or two methods of solving it. Okay, and we have seen it for a uniform force, we have seen it for a non-uniform force also. Okay, now let us move on to the next one. So here, the problem here is, it says work done by a massless chain in lowering a block. Okay, so it's a misconception also here. Some students make a mistake. I'll highlight what is the mistake that they do. So the question here is a block of mass 30 kg. The block of mass 30 kg is being brought down by a chain. So you have a chain. This is a mass 30 kgs. So the chain has no mass. Okay, this has no mass. It's just a string-like thing. If the block acquires a speed of 40 centimeters per second in dropping down 2 meters, that means let us say it started from here, and I have moved it down. I have just dropped it down like this. Okay, when it came here, this had a distance. It has moved down by 2 meters, by just 2 meters, and as a result of this, the speed here is 40 centimeter per second. Note it, it is centimeter per second, not meter per second. Okay, so convert it to meter now itself, 0.4 meter per second. Okay, and then find the work done by the chain during the process. What is the work done by it? Most of them, what they do is, since they see that this does not have any mass, so we need to consider only work done by this. And let us use work energy theorem. Work energy theorem says that when it was being lowered down, okay, it came down like this. So as a result of it, either you can do mgh here. Okay, so you can just do something like, what is m here? 30 kg is 30 kg multiplied by 10 multiplied by 2. Okay, I can do it like this. Or this also I have got a few answers. The other one is that you directly use the work energy theorem. Okay, work energy theorem states that the work done in total work done is equal to the change in kinetic energy. So here the let me assume that the velocity was 0, and here it has a velocity v, which is 0.4 meter per second. And as a result of it, the total work done in lowering the block here, okay, is nothing but half a v square. That's what they do, and finally get an answer. But this is incorrect. Why is this incorrect? The reason is because, see, you have a string. The string also does some work over here. Okay, we did not consider that. So actually, when we say work done in lowering the block, so there are two things that has been happening. One is there's a change in potential energy. Then there's a change in kinetic energy. We have only accounted for change in kinetic energy here. Even that has to be accounted. Okay. So therefore, actually speaking, this should be work done by the string or the chain, work done by the chain plus work done by the mass should be equal to half mv square. This is how you have to use it. Okay, but we did not use it like this. Okay, now let us start. Now let me do it by two different methods. Okay, why one method? One method is always boring. Okay, so towards it, now the chain is being moving downwards like this. First thing what we'll do is, let us find out by kinematics method. Kinematics method. What does kinematic method say? Kinematic method said that the work done is equal to force multiplied by displacement. This is what it tells you. Okay. Now, what is the force acting on it? Don't tell me it is equal to m into g. It's definitely not. Right? Okay. Now let us do this. So let us apply the free body diagram over here. Tension is acting here. This is moving down with an acceleration, which I do not know. This is your mg here. Okay. I need to find out this. So applying free body, I can now say that mg minus t is equal to ma, or I can now write, what is this now? What is m here? 30. 30 into 10 minus tension. Hey, is the tension known to me? Tension is not known to me. What is being given? Let us read it once again. Block acquires a speed of 40 centimeters per second. Okay, so this velocity is known, which means this velocity is u equal to 0 here. This velocity is v is known. It's a constant acceleration because gravity, right? So therefore, I can determine this value of a. Before we start this equation, I should get the value of a here. Let us get the value of a. I can apply equations of motion here. So I will do V square equal to U square plus 2s. And then V was seen to be 0.4 final velocity, which means 0.4 square. Okay, let me write 0.4 square is equal to initial velocity 0 plus 2 into A. I do not know. And the value of S is nothing but 4. 2 meters, right? 2 meters, yeah. 2 meters. Okay. So as a result of this, now I have 0.4 whole square is 0.16. This should be equal to 4A, or A should be equal to 0.04 meter per second square. Okay. So let me keep this block aside. I may need to go to the second slide also, I think. Okay, let us do. Okay, so I have got the value of A. Let us substitute this. Now 0.04 A, then I can get the value of tension directly here. Okay, I'll do one thing. I'll take this MA inside. I'll take this MA inside here and push this tension outside, which means it should be 30 into 0.04. This should now be equal to tension. So what I have done is, I've taken this one inside, tension T, I have pushed it outside. So when I do this, I get the answer as 300 minus 30 into 0.04. How much will it be? 3 4s are 12. Will it be 0.04 would be 3 into 0.4, right? Yeah, 3 into 0.4, 1.2 minus 1.2 is equal to T. In other words, the value of tension in the string is nothing but, are we doing it correctly? Yes, we are doing it correctly. Tension should now be equal to 288, 298 or 298, 298, my God, made a mistake. 298.8 Newton. Okay, this is what is the tension we have got. Okay, next what is that we need to do? Now this tension, okay, now this block is now made to move downwards. Simple. We have to calculate what is the value of W here. Now how do I calculate the value of W? W is nothing but you multiply this tension multiplied by S here. What is S? 2 meters. So therefore this W is equal to this force. What is this force here? What is that which has been asked here? Okay, wind the work done by the chain. Okay, chain does not have a mass, but it has a tension, a pulling force. Okay, it tried to pull it upwards, but unfortunately the block pulled it downwards. Right. So therefore now this is tension dot S. And what is tension? 298.8. Displacement is downward. What is downward? 2 meters. 2 meters. Okay. Now you see this is a dot product. If it's a dot product, then there should be cos of T, angle between them. What is the angle between them? This side, tension is pulling upwards. Then the way how it went downward, displacement of the object is downwards. So this should be cos 180. Right? Angle is 180. So this should be 2 8s are 16, 1 2 8s are 16, 1 2 9s are 18, 19, 1 2 2s are 4, 596, and this is negative. Minus 596.6 Newton. Okay. So have we done it correctly? 2 8 6 I'm sorry, this is 7 here. 1 carry here, right? Multiplication basics, we are doing mistakes. Okay. So 597.6, what is this unit? Not Newton here. This is distance, time multiplied by, force multiplied by displacement is joules. Joules. Okay, this is the answer we got. Okay. Just give me a moment. I will include one more slide. Otherwise, you will not be able to work out with this slide. It will be very clumsy here. There is it. I'll insert one more. Okay, so the answer that we have got is work done is equal to minus 597.6 joules. This is the work done in lowering, work done by the tension in lowering the object by a distance of 2 meters. Okay. Let us do the second method. What was the second method? Let me go to first method. First method I had wrote here is nothing but kinematics. The second method I said this method, work energy theorem. Okay, using work energy theorem. Using work energy theorem. Don't worry, the spelling is incorrect. Okay, I made it the correct one. M2 is nothing but work energy theorem. Now, how do we do this? Now, with work energy theorem, what did I say? I said work done by the chain plus work done by the mass. This should be equal to half mv square minus half mu square. The change in kinetic energy. So towards it, work done by the chain. That's what we need to find. Keep it aside. Work done by the mass. What is work done by the mass? You had a mass like this, okay, 30 kg, and then you made the mass to come downwards like this, right? So this was by a distance of 2 meters. 2 meters. So therefore, now the potential energy here is seen to be, how much is the potential energy? mgh. M is 30 kg multiplied by G multiplied by H. What is H? 2. Should now be equal to half mv square. What is half mv square? Half into 30 into 0.04, the whole 0.04, right? Because here it is, what is this now? 40 centimeters seconds, right? 0.4 whole square should be 0.16. I made a mistake once again here. 0.16, okay. 0.16. And now what we do is, let us compute this value. Work done by the chain is equal to 30 into 10 into 2 is, how much is it? This is 6600. So this should be half into 30. It should be 15 into 0.16 minus 600. Now let us find out what is this value. What is 15 into 0.6? 15, 6 are 90. 9, 15 ones are 15 plus 9 is 24. 2.4. 2.4 minus 600, which will be equal to how much once again? Which will be minus 597.6 joules. Let us cross verify. Did we get the same answer? 597.6 joules. 597.6 joules. Wow, great, right? Okay, so now you observe that you can do the same numerical by 2 methods. Kinematics method, what you need to do is you are directly finding out the tension. But here, in case of work energy theorem, you should know how to do this. It's nothing but the total work done is equal to change in kinetic energy. Now, which one is easier? I know you will definitely say work energy is much easier. Okay. Most of the problems, energy methods will be very, very easier as compared to all the other methods. Okay. So with this, let me stop here. And in the next video, we'll see further some more examples, okay, on how to do work energy. I think the next example would be, like, for example, now we have discussed only one mass, okay, which has been lowered like this. The next what I'll do is I'm going to lower 2 masses. Yeah, what is so special? 2 masses means what? I'm going to put 2 masses like this and going to lower. Then I won't do this, right? Nobody will watch this video. So 2 masses definitely I'm going to lower, but with a pulley, like this. I'll have 1 mass here, I'll have 1 mass here, and then I will lower this one and this will go upwards only. In that case, what will be the work done? This would be the question. Okay. Wait until tomorrow and watch this video. This is really going to be an eye-opener as how to work on work energy. Thank you, friends, for watching. Like this video, do like, share, and subscribe to my channel for more updates.